Hey guys, we are going to look at a polynomial inequality. I'm not gonna lie, these are kind of fun to solve, but if you don't agree with me, that's okay. All right, so when we are solving something that has an equal sign, we're looking for x equals something, right? But here we have an inequality, so we're looking for a range of numbers that x can be, right? So the first thing I'm going to do here is I'm going to get everything on one side so that there's everything on one side and 0 on the other side, okay? So to do that, I'm just going to add x cubed to both sides and subtract 9x from both sides, okay? Then I'm going to write this side in descending order. So I'm going to start with x to the third minus 6x squared minus 9x plus 54 is greater than or equal to what's left over here is 0, right? Okay, we're feeling good about this. The next thing I'm going to do is factor this. I know if you ground, it's okay. It's coming in handy now. If you need a factoring review, I will link one in the corner. I'm going to factor this pretty quickly, okay? So I notice from these two, I can pull out an x squared. I'm going to do it over here, okay? Pulling out an x squared, which leaves me with x minus 6. Okay, and then from these guys, I can pull out a negative 9, which leaves me with x minus 6. And then look, we have that x minus 6 we can pull out. So I end up with x squared minus 9 times x minus 6. Okay, and then I notice this is a difference of 2 squares. So I can factor that down to x plus 3 times x minus 3 times x minus 6, okay? I'm just going to rewrite that over here really fast. So if I were to multiply this all out, I would get this, right? Okay, the next thing I'm going to do is, if this were an equal sign, again, I know it's not. If this were an equal sign, I would then set each of these equal to 0, okay, to get my answers. But you're like, it's an inequality. I know. But for a second, we're going to pretend it's an equal sign to find where this will get this side of the equation to be 0. Okay, so I'm going to set x plus 3 equal to 0, x minus 3 equal to 0, and x minus 6 equal to 0. So we're setting each of these parentheses equal. This one I'd subtract 3 from both sides, get x equals negative 3. This one I'd add 3 to both sides, get x equals 3, and this one I'd add 6 to both sides and get x equals 6, okay? So when I plug these numbers in, if I plug in negative 3 for x, or 3 for x, or 6 for x, I'm going to get 0 on this side, okay? So I know these numbers are important, so I'm going to draw a number line. Yes, we love number lines. Okay, so I'm going to have negative 3 over here, 3 here, and 6 here. This is just to give me an idea. It doesn't have to be perfectly to scale, right? So I know that I can plug in negative 3 and I will get 0 on this side, and 0 is greater than or equal to 0, right? So I can put a closed circle here. Same with 3. If I plug in 3, I'd get 0 on this side of the equation, which 0 is greater than or equal to 3. Oh my gosh, 0. 0 is greater than or equal to 0, sorry. And then if I plug in 6 over here, I'd get 0 is greater than or equal to 0. So I know that those points work, okay? But we also have that greater than, right? It's anything greater than or equal to 0. So any number that you plug in that is 1, 2, 3, 4, 5, 6, literally up to infinity, any number that you plug in that is greater than or equal to 0 works. So I know it's more than just these 3 numbers, right? So the question is what range of numbers is it? Is it all the numbers less than negative 3? Is it all the numbers between negative 3 and 3? Between 3 and 6? Or all the numbers greater than 6? Which range of numbers is it? So what we're going to do next is we're going to test some points and use some sign analysis, okay? So I'm going to pick a point that is less than negative 3. So let's just go ahead and pick negative 4, okay? So if I were to plug in negative 4 to this equation, I'm actually not too worried about what the number answer is going to be. I just want to know if the answer is going to be positive or negative, Okay, so follow along, see how this kind of works. So if I were to plug in -4 here, I'd get -4 plus 3, which would leave me with a negative number, right? If I were to plug in -4 here, I'd get -4 minus 3, which would give me another negative number. If I were to plug it in here, -4 minus 6, it would be another negative number. When I have a negative times a negative, I get a positive, times another negative, I get a negative, right? Whew, that was a lot of negatives. So it was on this side of the -3. So this range is negative. Now, if you're like, what the heck is she talking about? Why does this work? I'll show you at the end why this works, okay? All right, next we're going to plug in a number between -3 and 3. Let's go ahead and plug in 0, okay? So if I plug in 0, 0 plus 3 would give me a positive number, right? 0 minus 3 would give me a negative number. 0 minus 6 would give me a negative number. A positive times a negative would give me a negative. Negative times a negative would give me a positive, okay? So this range would give us a positive number, okay? Now, if you're like, that sign thing is just weird to me, go ahead and plug in the points and get the actual numbers if you want to, okay? All right, let's pick a number between 3 and 6 to plug in. Let's just plug in 5, okay? So if I were to plug in 5, I'd get 5 plus 3, which would give me a positive number. 5 minus 3, which would give me a positive number. And 5 minus 6, which would give me a negative number, right? Positive times a positive would give me a positive. Positive times a negative would give me a negative, okay? So this range would be negative. And then we just need a number larger than 6. Let's just pick 7. You could pick 500 if you wanted to. Okay, so 7 plus 3 would give me a positive number. 7 minus 3 would give me a positive number. And 7 minus 6 would give me a positive number. Positive times a positive times a positive is positive. Whew, that was a lot. Okay, so the numbers larger than 6 gave me a positive answer. Okay, now we go back to this and say, they are wondering where this is greater than or equal to 0. So any number that's positive is going to be greater than or equal to 0, right? So where is my graph positive? Here and here, right? So if I plug in any number from -3 to 3, if I plug that in, I'll get a number that is greater than or equal to 0. If I plug in 6 or any number above, I will get a number that is greater than or equal to 0, okay? All right, next we're gonna write it, our answer, probably how your teacher wants to see it, and then I'm gonna show you why this worked, okay? So your teacher will probably wanna see it either in interval notation or just written as an inequality, okay? So we're just writing what x can equal. Let's first write it as an inequality, okay? So here, x is greater than -3, right? But I'm going to write -3 on this side. So it's going to go like this, okay? And less than or equal to 3, right? Wouldn't that represent this little band right here where x is, it's eating the x because x is bigger than the -3, and it's eating the 3 because the 3 is bigger than the x, right? And we use the equal sign because it can be -3 and 3, okay? But that's just this part. It can also be anything bigger than 6, right? So it can be this, or x can also be greater than or equal to 6, okay? X can be any number in that range or 6 or bigger, and you will get a positive answer here, meaning it is greater than or equal to 0, okay? Now let's write it in interval notation. So to write this one in interval notation, x can be from -3 to 3, and I used brackets because it can be -3 and 3. Or x can be from 6, again a bracket because it can be 6, all the way up to infinity. And infinity always gets a parenthesis, right? Because you can't actually be infinity. And then we do a little u to show that those are united, they're together, okay? So that, oh gosh, that is what x can be, okay? That's the same answer, just written 2 different ways, depending on how your teacher wants it, okay? Now, if you're like, okay, that's cool, I'm glad we got our answer, but why did that work? Good question, I'm gonna show you, okay? If I were to have graphed this, or you can think of it as graphing that, okay? I would be graphing a polynomial. If you need a review on how to graph polynomials, guess what? I have a video for you. But if I were to graph that using end behavior and multiplicities and all of that fun stuff, the graph for that would cross the x-axis at -3, 3, and 6. Remember how we set those equal to 0, okay? And then, again, using my end behavior and things I know about graphing polynomials, I know the graph would look something like that. Okay? So, remember we were looking where it was greater than or equal to 0? Look at where it's greater than or equal to 0, guys. Where it's above the 0 is from -3 to 3, right? And from 6 to infinity. Okay? So that's why that sign analysis thing works. Isn't that cool? Oh my gosh, I love it. Okay, if you need some more examples, I will link a playlist for you. Thanks.